right, hey, welcome back for week 6 of our ACT prep. This week we're going to be working on 5 new questions. And so we'll just get started with number 1. So number 1 says, in the first 4 of 5 consecutive days, Martha delivered 144, 152, 139, and 171 newspapers. How many newspapers did Martha deliver on the 5th day if the average number of newspapers she delivered per day during the 5-day period was 155, okay? So what I would do is I would go ahead and let's set this up in the actual equation, and then we'll solve it in the numeric solver, okay? This is an average problem, so it's number 1. That's why it's a little bit easier because it's at the beginning. Hey, would you do me a favor and just answer that and see what they need? Okay, so let's go ahead and let's get this written out. Okay, so on the top, well, hold on. There we go. Okay, so on the top part of this fraction, which is the numerator, we're gonna put,
Did I leave something in this class? Like an envelope or something?
Oh, you know what? I did not see anything. I'm sorry.
Okay.
Yeah, sorry. I'll look around for it afterwards, but I didn't see anything laying around, okay? Okay. Okay, so we're gonna put each of the numbers that she delivered on the top, and we're also gonna put an X, okay? So let's see, we're gonna do 144 plus 152 plus 139 plus 171 plus X. Okay, we have to have that X because that's what we're trying to find. How many newspapers did she deliver on that next day? On the bottom part of your fraction, or the denominator, we're going to add up how many numbers we have, including the X. So 1, 2, 3, 4, 5. So 5 goes underneath because this is an average problem. And then on the other side, we're going to put what they told us the average is supposed to be, which is 155. Okay, so you're going to go ahead and go into your numeric solver. So math, arrow up, enter. You're going to need a fraction in your top box. So this will be your top box. And it does have to be a fraction. And then on your bottom box, just 155. And you'll hit either alpha enter, or you'll hit graph twice slow. Okay. Do you guys feel like you're getting faster with your calculators? A little bit? Okay. I would say if you don't feel like you're getting faster, you're probably not practicing enough, okay? Trying those difficult problems where you have to quickly go and try to enter some things in. All right, once you get it, tell me what y'all got. So 169, right? I don't know why those calculators do that sometimes, you guys, but if you end up with that calculator that says 168.99999, we always just round that up, okay? Okay, so your answer for this one is 169. Does that make sense to you guys? Yeah. It kind of does to me too. You know, another thing that you could do if you didn't remember to go to the numeric solver, you could just add these together and then just keep trying each answer. So like you take these 4 numbers and then add the 5th number and divide by 5. See if you get 155. Okay, if that doesn't work, you can add up these 4 numbers, get the next number, 169, divide by 5, and see if you get 155. Okay, so the numeric solver is not the only place. You could also just add up all the numbers and divide by 5. Okay, make sure you're not dividing by 4. We've got to have the 5 under there. Okay, okay. Let's go on to the next problem. Okay, we're going to do problem 12. Okay, problem 12 is probability. So it says if a coin is randomly chosen from a bag that contains exactly 4 pennies, 3 nickels, and 8 dimes, what is the probability that the coin will not be a nickel? Okay, so the first thing we want to do is we just want to add up how many we have total. So we have 4 plus 3 plus 8. Okay, so that's 15 coins, okay? So 15 will be our bottom number. The bottom number is always the total, okay? So we'll have 15 on the bottom. And then it says, is not a nickel. So we'll add up all of the other things besides nickel. So the pennies and the dimes, so that's 12. So my probability that I'm gonna not pick a nickel is 12 out of 15. Do you see that sitting there? Is that answer here? No. Put it in a fraction in your calculator and it will reduce it for you. So you're gonna hit alpha and the button next to it to get your fraction. So alpha, and then you'll hit that x, t, theta, I think it's an n. So you'll hit that button, okay? And it'll get you your fraction and you put 12 over 15 and hit enter, and what answer did it give you? 4 over 5, yes sir. So that would be F. Okay, did you guys know that calculator will do that for you? Okay, so if you are ever dealing with fractions, make sure you're using the calculator, okay? It'll add them up for you. It'll even give you your common denominator and you don't even have to figure it out, okay? If you have mixed fractions, it'll add those together too and tell you what your new fraction is, okay? Okay, let's go ahead and we'll go down here and do 24, okay? All right. So I like 24 because we're talking about a circle. So when we're talking about statistics, you guys, and a circle, we're always talking about percents. They will never use anything else in a circle besides percents, okay? So we're gonna have our circle. Let's see, I'll do it over here actually. Okay, and then it says, Mary drew a circle graph, which I drew, that included all of the various types of flowers in her garden. The garden included the following: 20% tulips, 25% daisies, 15% roses, and 10% pansies. The last sector of her graph included the remaining flowers that were not tulips, daisies, roses, or pansies. What is the degree measure of the last sector of the circle graph? Okay, so you could do a few things. You could draw this out and you could put a few things in here, okay? But here's the easy way to do this. Let's add up all our percents, okay? Just add them up. So 20 plus 25 plus 15 plus 10, we're adding them. Okay, add them all. 1, 2, 3, 4, 5. And I actually, even on this, I did, so let's not do this guy. Because we needed 5 sections, and I obviously did way more than 5 sections, right? So what was your percent when you added them up? 70%, okay? So if 100% is my total, and it will be the total, will be 100%, okay? How many more percents do I have left? 30. So 30% is your answer, and that will be all of your remaining flowers. That's an easy one, you guys, okay? But you have to know that with statistics and probability, if they're talking about a circle, it adds up to 100%, and it's always percentages, okay? Anybody have any questions about that? No? Seems pretty easy, right? Okay. Hopefully it looks like that on the test, yeah.
Like, don't you have to like convert the percentage to degrees?
You do not for this one, no. You do not, because in a circle, it's always 100%, okay?
I'm saying like it's 360 degrees, so 80% of that, when it's like 80% over 360 degrees.
So what do we got?
I'm at 70% over 360.
Oh, our answers are degrees is what you're saying. Mm-hmm. Oh, I gotcha. Okay, so hold on. Yeah, so she's right.
Then you multiply it up to get 30%, which would be 36 times 3, which is 108.
Okay, awesome. So really 108. So guys, we would have gotten this wrong. And that would have been Miss Barden's fault, right? Because I looked up here and I saw all these percents, and then I assumed that those were percents, and they're not. They're degrees, and that was a very good catch. Good job. Okay, so guys, let me just explain it to you one more time. So she took 360. She multiplied that by 10%, so by 0.10, and she got 36. Okay, so 10% is 36. We know we need 30%, so then you would just do 36 times 3, and that's 108. Okay, 108. Did I describe that good? You guys good? Okay. All right, I'm gonna get rid of this one. Now, I'm gonna be honest with y'all. I did not think we were doing this week, so I didn't even practice. So we'll see how this goes. All right, let's get back up here and we'll do this one here. Let me take this down a little bit just so we can see it. Ugh, so tiny. Okay, so question 3 says, Alice designs a dartboard that has exactly 5 sections. Let's see, let's make sure, 5 sections. Okay, they are red, blue, green, yellow, and white. Okay, she wants to design the board so that each section of the board has a 20% chance of being hit by a randomly thrown dart that lands somewhere on the board. Alice randomly throws 600 darts that land on the board. The result of the throws are shown in the table below. Based on the results, which of the following modifications to the board would best help Alice achieve her design goal? So the first thing is you want to do 600 times 20%. Okay, so whoops. I feel like it should read my mind. It knows I want to write on the board. Just put my little thing up here. Okay, so 600, come on, 600 times 0.20. And what do y'all get for that? 120? Okay, so all of these sections should be relatively close to 120, okay? So if I'm just looking up here right now, which one do you think we need to modify? The yellow, good. And then is there one that's way big? Which color? Blue. Okay, so somehow we're probably going to manipulate the blue and the yellow, right? So let's read our answer options and see if we can find the one that seems the best. So A says Alice should increase the area of the yellow section and decrease the area of the red section. No, okay. I don't like that one either. Okay, Alice should decrease the area of the white section and increase the area of the green section. No, I don't like that either. Okay, Alice should decrease the area of the blue section. So far that's good, right? And increase the area of the yellow section. Yes, that's right. I was reading and accidentally started reading the one above. And then just double check the last one to make sure that it's not a better option. So Alice should increase the area of the blue, and we know that that's not right. The blue is the bigger one, so we want to decrease it, right? So not the right answer. Okay, so far I feel pretty good about the probability section. What do you guys think? Not too bad. Just got to make sure that you don't screw up percents and degrees. Make sure you're really looking at it, okay? And you guys, did I tell you guys I'm taking the ACT on the 11th? Mm-hmm. So I'm going to Huffman and I'm sitting down to take the ACT with all the high school kids. So that'll be interesting. But I'm taking it because I'm just kind of curious like what you guys feel when you're sitting there. And it's been a long time for me. Obviously I'm 53. So I probably took this like 40 years ago, right? So, okay. Let's see. So question 45, and I'm going to make this a little bit bigger now that I can. Okay, there we go. Okay, so question 45. So this is the last question on the ACT, right? So they think it's a little bit more difficult. So a spin wheel is divided into a red sector and a blue sector, okay? I won't draw it out yet. There are no other outcomes. The probability of the spin wheel stopping on the red sector is 3 times the probability of stopping on the blue sector. So I'm going to draw a circle. And let's just say, so the probability of stopping on the red is 3 times greater, right? So I'm going to make it bigger. What do y'all think about this one? What would you do? Anybody? No? Okay. So let's try this. So it stops here 3 times, right? And then this would be 1 time. Okay. So let's do, why don't we do 3 times 2 plus 7 divided by 4. I don't know if this is going to work, but let's try it, okay? So 3 times 2 plus 7, and then we'll divide all of that by 4. So what was it? 325. Okay, so let me just describe to you why I thought about it this way, okay? So I'm gonna, actually, here's what I'm gonna do. I'm gonna actually divide this into 4. So each red would be 2. Okay. Okay. So each red would be 2, and then the blue would be 7. So, and we don't know what it's gonna land on. But let's just, if one spin went all the way around, it just wants to know like what is the total expected value of a whole spin, okay? So it would only land in one place. So I would have to divide by 4 because I'm only spinning and it landing one time, right? But I don't know where it's going. So I did 3 times 2 because it could be any of those 3 and they're $2 for each one, okay? So that's $6. And then this other one is 7. So 6 plus 7 is $13 for the whole spin, okay? And then I divided by 4 because there's 4 different places it could land, okay? And so if you divide all of that by 4, you get $3.25 is the expected value of each spin in the game described, okay? Martha delivered 158, 142, 167, and 147 newspapers. How many newspapers did Martha deliver on the 5th day if the average number of newspapers she delivered per day during the 5-day period is 155? Is this the first one, you guys? Is this the section 1? Okay. So let's do it the other way this time, okay? We did the numeric solver last time. You can do the numeric solver because it's quick, but I want to show you the other method just so you can see it just in case. Like you can't remember the numeric solver. So we're going to add all of these numbers up, okay? So 158 plus 152 plus 163 plus 147 plus 155. Okay, hit enter and then divide by 5. Did you get 155? No? Would 153, so that's not what we need, right? Okay, so it's not that one. Let's try it again. So don't, in your calculator, you guys, let me, did you add them all up together? Or are you doing something different? Okay, so listen, in your calculator, once you have all those in one line, don't type them all back in again. Go up and highlight that line where you typed all the numbers in and hit enter and it'll bring it back down. And all you have to do is change the last number. Go back over top of the last number you added in and make it 165. Then hit enter and see if you get 155. Okay. What'd you get that time? That was 155? So your answer is 165? Is that right? Okay. Those, did you put it in the numeric solver? What'd you do? You didn't, okay. This is actually, I want to show you guys this. I know you guys can't see this, but I'm going to show you like kind of individually. Do you see how she entered this in the calculator? Mm-hmm. Okay. Do you know what the mistake was that she made?
Does it multiply differently?
So she divided it at the end, right? So what happened?
I think it did everything backwards.
It did only the last number, right? Yeah, do you kind of see it? Okay, yeah. Yep, that's it. Yeah, 165. And you got all those zeros with the 1 back there, right? Okay, so here's what happened, you guys. Do you guys all see this? So look, it added up all the numbers, but the only number it divided was the last one. So you have to be careful. What I would suggest is you add them all up, hit enter, and then divide, yeah. Because your calculator is going to do PEMDAS in the right order. So if you, the other way you could do it is you could put them in a bracket, do the addition in a bracket, and then divide at the end, okay? And then you'll get it. Okay, so we got 165 by doing the numeric solver, or add up all the numbers, add in each answer, divide by 5, and then see if you get the 155, okay? Okay, question 3. Alice designs a dartboard with exactly 4 sections, red, blue, green, and yellow. What shape is a dartboard? Circle, good. She wants each section to have a 25% chance of being hit. she throws 800 darts. So our first part that we need to do is 800 times 0.25, right? So 800 times 0.25, it's 200, okay. So that means that each of these sections need to be close to 200, okay? So if you look at the red, it's 180, that could come up a little bit, right? The blue is 220, it could come down a little bit. And honestly, the green and the yellow are so close, we're probably not gonna manipulate those at all. So which modification would best help her goal? So A says she could increase the area of the blue. Do we wanna increase the area of the blue? No, we don't. So we'll just go ahead and get rid of that. We're not even gonna read the rest. Okay, so we can decrease the area of the blue. Okay, that sounds good. And then increase the area of the red. That sounds good to me. So this is probably our answer, but let's just double check that there's not something better. So this one says we're gonna increase the area of the green section and decrease the area of the yellow. You could do that, but that's not our best option, right? So we're not gonna pick that one. D says you can decrease the area of the green, okay? And then you could increase the blue. We wouldn't wanna increase the blue anymore, so we're not gonna do that one either. So the best answer here is B. We're gonna decrease the area of the blue from 220 and bring it down. And then we're gonna increase the red, which was at 180, and bring it closer to 200. Okay. How are you guys feeling about these type of questions? I feel like they're pretty good, right? I feel like you guys are getting pretty good at them. So, okay. Let's do 24, and then we'll go back and, so we'll go down and get 12, and then we'll go up and get that other one, okay? But let's do 24 since it's right here. Okay, so we have that circle graph with the flowers again, okay? So let's add up our percents and figure out what's left over. So you'll do 15 plus 30 plus 20 plus another 15. So that's 80%, right? So we have 20% left over. Okay, so let's do the method that she showed us earlier, which was to take 360 and multiply it by 0.1, okay, which is 36. And then all you would do is multiply the 36 by 2 because we need 20%, not 10%. So times 2, which is 72 degrees. How do you guys feel about that one? Good, okay. The blue is 0.8. A player wins $10 for the red and $5 for the blue. What is the expected value of each spin? Okay, so we can do this a couple of ways. You could do your circle, and then we would need 5 divisions, right? Basically, if I did everything by 0.2, and total is 1.0. Okay, so kind of just hear my logic out. So it's 1.0, but everything is by 0.2s. So let's divide it into 10 sections, okay? So there's that. So what do I got? 1, 2, 3, 4, 5. 1, 2, so that's still, I need one more. Let's do right here. Okay, so that's 10 sections, okay? So the red is just one of these 0.2s, okay? So this is 0.2, and this is red. And for red, you're gonna get $10, okay? Okay, then for all the others, those are gonna be 0.2 for blue. So, did I do this right? 0.2, 0.2. I don't think I did, y'all. Because 8 divided by 2 is 4. Why do I have a whole extra circle over here? Let's just get rid of half a circle. We'll get rid of that side. Okay, so 0.2, 0.2, 0.2, 0.2, right? So 0.2 is gonna be, this is blue. And then you have this is $5 per. So $5, $5, $5. Okay, That looks really crazy. I'm sorry about that. Okay, we have half a circle. We do have all of the sections. So we have 0.2 that's red where you get $10. And then we have 4 0.2s where you get $5 for each, okay? I divided this so that I just don't make a mistake with my addition. But you guys, you don't even have to draw a picture, right? We just multiply the section by the amount. So, and then we just add them all up. So we've got 5 sections, right? So we've got 10 and then 5 4 times. So 5 plus 5 is 10. And then you've got another 10 and then 10. So 30 total. Okay. So $30 total. And then we want to divide that by 5 sections. Okay. So divide by 5. And that means that each spin has a potential to get you an average of $6, okay? So $6 is your answer for this one. I really don't feel like I'm describing this very well to you guys, and I'm sorry. Sometimes it is difficult to explain how to do something, you know what I mean? Especially when you haven't practiced a bunch, right? And like I said, I haven't actually practiced these, so, but let's just kind of walk through this, okay? So I had a 0.2 that was red for $10. And then I had, this was 0.8. So 0.2 plus 0.2 plus 0.2 plus 0.2 is 0.8. And each one of those I have a potential of making $5 if it lands there. Okay, so then you just add up your dollar amounts and you'll divide it by the total number of sections you have. So 30 divided by 5 will get you $6 potential per spin that you're going to make, okay? All right, you guys feel okay about that? Okay. Okay, so this was the last week of the ACT prep where we're working on like this crunch program that was from CERT. So like the next couple of weeks, we only have like 2.5 weeks until we take that test. So in class, we're going to be making our actual playbook. So what we might do when you guys come on Thursdays, we might make your playbook. So if you're in my class this semester, you'll be starting it in class. So several of you have me right now, but some of you don't. So like you'll make yours in here so that you have this playbook, because you need to pick, depending on your level. Remember, if you're going from level 1 and trying to get to level 2, we need to pick 15 questions that you are going to commit to knowing very well, so that if you encounter them on the ACT, you're going to get a great score, okay? If you're moving from a level 2 to a level 3, we need to pick 25 questions, okay? And then 35 if you're trying to move from level 3 to level 4. And remember, level 4 is a 25 or higher. So those you're gonna want to commit to 35 questions that you are gonna practice and know really, really well, okay? But you guys, we're just looking for growth. And you need to think about like, what is it that you need for your future, right? It's great to get our score report card higher, but if we just take care of you guys, that's gonna happen. Do you know what I mean? So like Skylar, are you planning on going to college? Okay, so you need an ACT score. Even though they don't say you need the ACT score, you're gonna take remedial math classes or you're gonna have to take a placement test if you don't have the score you need. So let's just get it now. So in class, I always tell you guys like, pay the price now so you don't have to pay it later, right? So let's just keep working, okay? We've got a few more weeks. That last week, we'll kind of take a break, but let's just keep working and getting better at this, okay? Does anybody have any questions or anything? Any concerns? No? Okay, all right, thanks for joining again.